Okay, kiddos, here is a video lesson explaining our solutions to practice quiz for Chapter 4, Part 2. This one's a little trickier than the first one, than Part 1, but here we go. Find the slope of the line that passes through the points. So, the difficult way to do this is to actually plot the points and then count the rise and run. You may do that. What I recommend is using our formula. So this is slope equals, it's frequently described, y2 minus y1 over x2 minus x1. So subtract the y coordinates and divide that by subtract the x coordinates. So for question number 1, see I did 3 minus 5 over negative 4 minus 7. Negative 4 minus 7. So y minus y over x minus x. You may do y minus y over x minus x. You will get the exact same thing. It's important to not mix them up though. So if you had done y minus y over x minus x, you'd get the wrong answer. Okay? So if you start with this, you have to end with this. If you start with this, you have to end with this. Okay, hopefully that made sense. So anyway, y minus y over x minus x, using this formula, this is what I get. Simplify, and for question 1, we get 2 over 11, 2/11ths. Number 2, here are our points. So I did y minus y over x minus x, x minus x. Remember, subtracting a negative, same as adding a positive. Oh, and we get a slope of 0. So, 0 over a number is 0, as we have here. However, if you are dividing by 0, so any number divided by 0, that is undefined or does not exist. You are not allowed to divide by 0. So what we get for number 3, when we do y minus y over x minus x, y minus y over x minus x, the x minus x gives us 0 underneath. That is undefined, so it would be a vertical slope. So you might plot those points if you were interested. So 1, 2, 3, 4, and negative 1, and 4, 3, okay, from this point. So plotted that point, and it would look like that. That is a vertical line, undefined slope. Aha! And if you were to plot these, it would be a horizontal line with 0 slope. Cool. So that's how we end up with these. 0 slope, undefined slope. Alright. What are we asked to do for 4, 5, 6? Identify slope and y-intercept of the line. Okay, so slope and y-intercept, we're probably going to want slope-intercept form, meaning y all by itself. Lucky for us, question 4, it's already in slope-intercept form, so we just say y-intercept is 2, slope is 7, piece of cake. Number 5, so let's see, where is our answer to 4? Okay, so there we go. Y-intercept is 2, slope is 7. Alright. 5, we're going to have to do a little rearranging. So here's our equation. We want y all by itself, so I subtracted 10 from both, I subtract 10x from both sides, leaving me with just this on the left, minus 10x, and then plus 30 on the right-hand side. I then divided both sides by negative 5, and negative 5. So all of those get, oh, I can't erase. I'm sorry, I just covered up all my work. Whoops. Oh, wait. Maybe I can do this. Nope. Okay. Oh, well. So what this says here is y equals 2x and then minus 6. So this gets divided by negative 5, and this gets divided by negative 5. My slope is 2, and my y-intercept is negative 6. Okay. Fortunately, Number 6 is very similar, in case that was confusing since I wrote over everything. So we want y all by itself. I'm going to subtract 3x from both sides. So this brings it over here, and it's negative 3x. I'm left with negative 8y on the left-hand side. So in the step going from here down to here, I am dividing by negative 8. Divide by negative 8. Divide by negative 8. Gives me positive 3/8, gives me positive 3, and just a y all by itself. So, y-intercept is 3, slope is 3/8, and there's the answer. Okay. Seven and 8. So we are asked to graph the equation. And we've done this two ways. One way is we've kind of used slope-intercept form, where we have plotted the y-intercept and then used rise and run to find another point and connected them. The other thing we've done is intercepts, where we plug in 0 and then plug in 0, solve for the xy intercepts, put those on the graph, and then connect them. So both ways work for any equation. The reality is that one of the ways will probably be a lot easier. So for 7, because it was already in slope-intercept form, I chose that. So I put the point at negative 1, and then I have a slope of negative 7 over 2. So it was like 1, 2, 3, 4, 5, 6, 7, and then 1, 2 to this. Or I could go backwards and go up 7, and then left 2. Okay, and there would be our line. I think that, no, that was for, okay, so that's what it did. You could also find the intercepts. It's going to be pretty weird with that x-intercept because it's negative 2/7, and so where to plot that might be a little sketchy. Number 8, I am going to, solve for intercepts. So it looks like what I'm showing here is, at first, I was like, okay, I'm going to add 4x to both sides, and then I'm going to divide both sides by 6, and I get this. So you could, this should be a, I don't know where that came from. We're going to just cover that up right there. Okay, 2. So we divided both sides by 6. So you could just simply put this into slope-intercept form and then graph. So it'd be a y-intercept of 2, and then up 2 and over 3. Up 2 and over 3, and that's not too bad, but you do have to do all this rearranging of the equation. So I said, well, let's find the intercepts instead, because this is kind of set up for it. 4 goes into 12 and 6 goes into 12, nice and even. So I put in a 0. Let's zoom out a little bit. Okay, so put in a 0, solve for y, and got y equals 2. So put the point here. Plugged in a 0 for y, solved for x, and got x equals negative 3. So I plotted that point here. Alright, and then connect them, and there's our line. So you could do slope-intercept form if you wanted, or you could find the intercepts like I did, plot them. You're going to get the exact same line either way. Oh yeah. Okay, 9. This was a little tricky because we're not ending up with these nice integers. You know, for these, it's like the y-intercept is 1, the x-intercept is negative 3, the y-intercept is positive 2. Here, we're going to get these fractions. Again, you may use a calculator at any point. Calculator. Okay. I strongly recommend bringing one because you're not going to be supplied with a calculator. So please bring your own. Strongly recommended. Okay. For number 9, here we go. So I think what I did over here is I'm plugging in 0 for x and then solve for y and end up with negative 7 halves, which is negative 3.5. Negative 3.5. So that's this point. And then I plugged in 0 for y and solved for x and ended up with negative 7/9. What? Negative 7/9. So on your calculator, that would be something like negative 0.7-ish. So somewhere around here. And then I connected them like that. Doesn't have to be perfectly exact, but there you go. The alternative solution I show here, where we could put it into, we could put it in a slope-intercept form by subtracting 9x and then dividing both sides by 2. So we have a y-intercept and a slope, and you could count the rise and the run if you'd like to. Alright, little tricky, we can do it. Lastly, 10. Okay, what's all these scribble scrabbles? Pencil, yeah, that would be recommended. Then you wouldn't have to scratch out stuff like I did. So for question 10, a campsite charges $12 per day for the site rental and $8 for parking. So it looks like you have to park once or pay for parking once, and then $12 per day. So total campsite charge in dollars is given by, this is the total cost, this is the slope, $12 per day, and then the y-intercept, which is the $8 that you have to pay once. D is number of days, and site is rented. Graph the equation. Okay, so you could look at this and say slope is 12, y-intercept is 8, and so plot your y-intercept, and then rise 12 for every 1, rise 12 for every 1, rise 12 for every 1, rise 12 for every 1. So I made a little table just to make sure I was getting those values correct, which it looks like I wasn't here. Oops. But after actually multiplying correctly and adding in whatever, we got some specific values, plotted some points, graphed it, voila. Hope you enjoyed viewing. Study. Thank you.